Hey, C6 again. Welcome to the second devlog of the SLFPS project, a movement shooter with inspiration from the Souls-like genre. In this video, I'd like to talk about the AI movement and behavior programming, both the problems and my current solutions as the project develops. So Unreal Engine 4 uses a behavior tree to power AI. It functions like the brain of the AI, where it performs logic to determine what to do at a given moment. It comes with this fancy node called the MoveTo. You'll find it in plenty of tutorial videos, as conceptually it's a very useful node since it's used to tell the AI to move somewhere. For the first version of the Mantis AI, that's exactly what I used. I wanted the AI to move somewhere, I used that node. But it turns out this simple looking node is a bit too simple. Say I want my AI to strafe. Find the location to the right of the mob and tell it to go there. Solved, right? What? Why? Why is it doing that? Is it lagging? Why you no smooth? So what seems to be happening is when MoveTo is provided an arbitrary location, the task doesn't refresh until it completes the move command. This becomes very apparent when I show the location with a line trace as I move around the mantis. The AI moves to the location that was given when the task was initiated, but the location doesn't change when the variable itself has been updated. What results is this odd movement pattern which just looks off. This stutter as it reinitiates a MoveTo also occurs when the location doesn't change. Here in this example, depending on the distance, I have the AI execute a different task. In this case, all of them are the same, which is to move to the player. But you can see here, whenever the AI switches to a different task, the previous MoveTo is cancelled. A new MoveTo is called, causing the AI to halt movement for a split second before moving again, causing these jitter in movements. Oh, here's another fun quirk about the MoveTo. The AI sits still if it fails to figure out a path to the given location. While this makes sense, this scenario occurs even when the player is jumping. So, this is what I came up with. An actor that's tied to each mob AI. The AI is told to go to this goal actor point thing. Then I have some code to control where to place this goal actor. In the blueprint, I have a loop that's checking if the mob is idle and therefore not moving. If so, call a new MoveTo towards the goal point. This way if the MoveTo gets cancelled, it quickly makes a new MoveTo. Now that I have a system separate from the behavior tree for movements, I'm able to do all sorts of fancy codes to control the movement behavior. For instance, a tracking mode that's able to handle player jumping properly. Predictive tracking, where AI leads to target. Strafe mode. Flank mode. Back away mode. Here's one I really like, curve mode. All of these modes have code to handle difficulties in terrain, such as strafe flipping directions when hitting a wall or near a ledge, or flank continuing down when near a ledge. What's nice is that the system was built to be modular, so I should be able to slap it on any existing or future mob and it should just work. Any newly added movement modes should also work with all mob that uses the system. This definitely took a while to build, but I'm really glad I did it. I think it'll really help allow the AI movement to be more dynamic and polished. Now that the AI can move to the player properly, another issue cropped up. What does the AI do? In the first version of the Mantis AI, I found it performed too robotically, too deterministic, and really the way the behavior tree works inherently makes it so. If this, do that. If that, do this. Getting an action to be performed by chance, while possible, is very clunky and jank. Let's look at the flying lunge attack. Here I have a random yes and no being generated every 8 to 22 seconds. Then when the distance to the player is between 1000 to 1700 centimeters, it will perform the lunge flying attack if the randomly generated boolean is a yes. It works, but is not flexible at all. Say a playtester noted the AI is using the flying lunge attack too often. What do I even change? I mean, it's probably possible, but it'll make the already mess of code even messier. Don't get me wrong, the deterministic nature of the behavior tree has its use, but I needed a different system to make a variety of actions occur by chance, which I can then fine-tune. So this is what I came up with. A task which outputs an appropriate action based on chance and other criterias. Then the behavior tree executes that action. Alright, tasks are what Unreal calls these purple nodes. They're used to do a thing essentially. Inside this task, it does 3 steps. First, it filters out all actions that shouldn't be performed, then it weighs all options with another set of criteria, then finally selecting one at random. Let's look at the strafe option. For the filter, I specified if the AI is too far away from player, don't strafe. Then for the weighing, if the previous action is not strafe, increase the chance of strafe. Conversely, if it was strafe, reduce the chance. If the AI is not in front of the target, reduce the chance. If the stamina of the AI is under half, increase the chance. If the AI is too close to target, reduce the chance. Imagine making this in behavior tree. I think my brain will explode. Anyways, so once all the available options are weighed, one is selected at random, and the AI performs it. The structure is honestly really simple, but it's easy to understand and tweak it so it's just right. With these 2 major systems in place, the mob now feels a bit more natural, less brain dead if you will. At least, I think so. What do you guys think? Any ideas on how to make them feel more alive? Let me know in the comments. And that's about it for this update. I hope you guys found this interesting, or maybe even learned a thing or 2. The next one should cover a few new cool toys I like to add to the player's arsenal. Subscribe so you don't miss it. Thanks so much for watching. Until next time, bye!